Hello and welcome to the fifth video of this series on how to use the TI nSpire. In this video, we'll discuss some more advanced techniques on the graph. If you're not really comfortable with how to use some of our more basic functions on the graph, I'd recommend checking out the last video. These things won't be super advanced, but if you don't know how to do things like convert between, how to go from this to like a relation graph or this to a parametric or polar graph, this video will be pretty confusing. I'm not going to go super in depth on that basic stuff because I did just make that past video. But without further ado, let's get into this. So most of the things that you're going to want to do on this graph, or pretty much everything, is going to be under your menu. So we already looked at 3 and 4 for changing between graphs and zooming in and out. Number 5 isn't too useful. I don't really ever use number 5. Number 6 is where most of our use is going to come from. So you can see we can find the zeros, the minimum, maximum, intersection, inflection, slope, integral, bounded area, and we even have a function that we can use to analyze some conic sections. So let's make use of some of these. So I'm going to start off with just f of x equals negative x squared. So we're just going to work down the list. If I go to Analyze Graph and then 0, I would use my keypad to move left and right. The other thing I can do, here I need to retype. The other thing I can do is if you just start typing numbers, right? If you just start typing a number and then click enter, it'll put that as your lower bound. So let's say I want my lower bound at -2. I could just type -2, click enter, and it'll put that as my lower bound. And then if I want whatever I want my upper bound to be, maybe I just want it to be 2. I just type 2, click enter, and you see it tells me that I have a 0 right here. Okay, so like you probably could have guessed this just by looking at the graph. It might even be faster to just use the solver. In fact, that's what I typically do. But I figure I'll just show you your options. And then pretty much all the other ones are very, very similar. This graph doesn't have a minimum, but I'll show you that you can actually still use it for a minimum. Let's say I put my lower bound right here and my upper bound right here. So you see, it gives me this value right here as my minimum, which seems weird because, I mean, I don't have any like hills or valleys right there. But the thing is the minimum will actually show you the absolute minimum on that interval. It doesn't necessarily show you just if I have a relative minimum. So it doesn't necessarily have to be a valley. It just tells you what is my lowest y value on that interval. So if I get rid of some of these, which you can do, by the way, by clicking on it and then clicking backspace or delete. And then the maximum works exactly the same way. I go here, I go here. See, there's my maximum. And then working down the list. Okay, so for intersection works in a very similar way. Let's say I graph x minus 3. Okay, so I have these two intersections. Then I'll go to intersection. Here's my lower bound. And say my upper bound is right here. So it shows me I have an intersection at -2.3 and -5.3. And then if I increase my upper bound a little bit, it shows me this other intersection at 1.3 and -1.7. So, I mean, in my opinion, I think it's much, much quicker to just do this like with your solver. Like in your solver, just set -x squared equal to x minus 3. But some people are quicker at different things. And yeah. So what else do we have? Okay, we have points of inflection. Okay, neither of these graphs have a point of inflection. Actually, oh yeah, neither of them have a point of inflection. So let's graph, I'm going to graph x cubed, y equals x cubed. Now if I go to Analyze Graph and then Inflection, set that as my lower bound, set this as my upper bound, you see it gives me an inflection at 0, 0. So if you're familiar with calculus, it's probably quicker to just take the second derivative and set it equal to 0. But this is an option you have. Let's see, what else? We have dy dx, which will tell us the slope at a certain point. I find it easier in this case to just type the number we're trying to look for. So if I wanted like the slope at 1, type 1, click enter, and I'll have a slope of 3. And then same kind of thing with my integral. Maybe I'll set my lower bound at 0, my upper bound at 2, and it shows that I have an area of 4. All right, getting rid of some of this for the sake of having space. The other thing that you can do is you can find bounded area. So it's not a very good example. This give me yes, okay, that'll give me a bounded area right there. If I do menu and then go to bounded area on 8, I can click my intersection points, right? They kind of just lock into place like that. And it'll tell me this has a bounded area of exactly 1. That's kind of nice. I did not plan that. And of course, I could have done it for this one down here, but you know. Well, the one that I actually use the most, and in fact, I think all of the ones I've just shown you are, I think it's much faster to just do it in your calculator page. But the one that I will go to the graph for, because in certain scenarios it actually is much, much faster, is the conic sections solver. So I'm going to go ahead and clear this. And I'm actually going to go to relation, because this is where it's a lot easier to graph conics. So to go to relation, and when I say conics, I mean things like ellipses, hyperbolas, circles, parabolas, that kind of thing. So I'm going to go to graph entry edit, and then number 2 for relation. So let me just graph an ellipse real quick. I'll make it a little bit bigger so it's easier to work with. There we go. So here is my ellipse. Now I can find these various different things by going to Analyze Graph, and then number 9 is for Analyze Conics, and I can find all these different things for my hyperbola. No, sorry, for my ellipse, but I would be able to find it for a hyperbola. So if I click center, okay, not too much of a surprise, 0, 0. If I go to vertices, right, negative square root of 10 and positive square root of 10, and pretty much for all of these, you're just going to click it and then hover over whatever conic you want. So if I wanted eccentricity, I'll click 8. You'd find eccentricity. Sweet. So that's pretty much how the conic solver works. I can try it for a different kind of graph. If I just make this a minus, yes, now we have an entirely different looking graph. But the principles still follow. Right? If I want to find the directrix of this hyperbola, I would click 5. And these are the two directrixes. Is that the plural of directrix? Yeah, so I get these two lines. Those are my directrixes. If I wanted the asymptotes of my hyperbola, I will click 6, hover over. It shows me the two asymptotes. Two more things. If I try to graph these kinds of things in like parametric or polar, for whatever reason, it does not work as well. So I'll give you an example. If I go to parametric, and here's an example, we'll make x of t equal to sine of t, and this equal to cosine of t. See, it graphs this circle. Actually, I'll make these a little bit bigger so it's easier to see. Right? So it graphs a circle. But when I go to 6, Analyze Conics, like I want to find the center, I try to hover over it, and for whatever reason, it doesn't work. So I'm not entirely sure why this is the case. I'm not entirely sure why this is the case, but if you're on the math test and you get an equation that's parametric, you should have some strategies in mind on how to convert something like this into a relation or into a function. I mean, or you can just learn how to do the math. Period. I mean, that of course would be ideal. And the same thing goes for polar. The polar does not always work the best. So let me clear this. Let me see if I can think of a polar conic off the top of my head. 3 over 2 minus sine of theta. I think this will give me a conic. Oh yeah, okay, this gives me an ellipse. So if I go to Analyze Conics, Foci, and I hover over it, see, it doesn't really give me anything. So just know how to convert into relation. A lot of the problems on the math test are not super difficult to convert into a relation. But that's about it. So my summary is pretty much the first 8 things on this analyze graph are things that you should just be able to do on your calculator page, and it will save you time anyway. Um, if you're really fast at conics, if you practice it a lot, you might not even need this. But conics, there's a lot of formulas to memorize, and sometimes when you're in the middle of a math test, you'll forget, so it's good to know where this page is. The last thing I'm going to say is that while this tool is really helpful, Mr. McCurdy has done a really good job of writing these tests such that these functions that the calculator has aren't as useful. So for example, um, he might just give you a question as simple as find the eccentricity of this ellipse if you know the major axis and the minor axis, which if you know the formula is like a 3-second question. But if you're only using the program, you have no way of knowing how to, like you have no way of doing it. It's just impossible. So still learn these formulas, still go over it. This is just for in a pinch if you forget the formulas or think that it would be faster in general. So hopefully you learned something. If you did, make sure to leave a like and subscribe. If there's something that you thought I should have mentioned that I didn't, leave a comment, and I will see you in the next video. I'll see you next.